Hello everyone! In this video we will continue to examine topic 1.2, uncertainties and errors, and in particular we will begin to unpack absolute, fractional, and percentage uncertainties. Alright, so on any physical measurement given in the IB for experimental work, and actually in science in general, you should always have an uncertainty. Okay? But there are different ways of representing that uncertainty, and they serve different purposes. The first kind is sort of the obvious one. This is known as absolute uncertainty, and it's the uncertainty expressed in the units of the quantity. So, for example, if I'm measuring a very large height, I might say 21.3 plus or minus 0.5 meters. And I might say for a time 1.23 plus or minus 0.15 seconds. So in our absolute uncertainty, we are simply representing that uncertainty in the unit of the actual quantity. By the way, this is how you should organize a measurement like that. Notice I have the value plus or minus the uncertainty, and then I have the unit. If you really want, you can put the unit again right here, but if you forget the unit on either the value or the uncertainty, so for example, if you say 21.3 plus or minus 0.5 without a unit, or if you say 21.3 meters plus or minus 0.5 blank, both of those will be counted wrong. So you need a unit that applies to either the entire quantity or to both. All right, so notice that when I represent a value and an uncertainty, I want the value and the uncertainty to match. And here's how it works. Notice that I will need my uncertainty, and the uncertainty will give us sort of a range of reasonable values. So 21.3 might be as large as 21.8, in my measurement, or as small as 20.8. Okay, so this could be plus 5 or it could be minus 5 on this decimal place. As a result, any additional significant figures on the actual value don't tell me anything at all. So imagine that I wrote that number as 21.3276 plus or minus 0.5 meters. Notice that if this is the true uncertainty, these digits tell us nothing. So what I need to do is figure out what my uncertainty is, and then use the last digit of the uncertainty right here. That should also be the precision to which I write this particular value. So if this is 0.5 meters, notice that the last value that I record in my actual measurement is 0.3, because it's the final digit or significant figure that tells me something. Notice it's not that this is one significant figure and therefore this is one significant figure. It's that this is one significant figure right here, and that significant figure is in the tenths place, and so I'm going to write my actual value to the tenths place. In an uncertainty, you also want to make sure that you have no more than two significant figures on the uncertainty itself. So 0.5 is a totally reasonable, but often if it's smaller than about 0.5, you'll give a second significant figure on the uncertainty. So I might say 0.15 seconds, or even plus or minus 0.10 seconds, for example. You want no more than two sig figs on the uncertainties. As a rule of thumb, you can always put two sig figs on the uncertainties, and I would encourage you to do so. Then, using that uncertainty, so this is plus or minus 0.15 seconds, you can then write the value being measured to the right number of significant figures. So if this were 1.23, notice that I'm going to the second decimal place, that is the hundredths place here, and that is as precise as I am writing this original value, even if my instrument or my average gave me more digits. This is how I should represent the value. Okay, notice that the additional significant figures on an uncertainty also tell us very little. So if this argument is true, then, for example, if I have the value 21.3 plus or minus 0.5032, well, if that 0.5 all on its own is restricting that value to be the last digit shown, then these extra values on the uncertainty tell us nothing about the quantity being measured, which means any more than two significant figures on that uncertainty are worthless. They tell us nothing about the value, and I would strongly encourage you, well, require you, not to write them. So uncertainties get two sig figs, and then you use the number of uncertainties on your, a number of significant figures on your uncertainty to give the number of significant figures on the actual value. This is in IB notation written as x plus or minus delta x. In the next video, we'll go through the fractional and percentage uncertainty representations.